talk about that as well. But thanks for that, Natasha. Really exciting stuff coming down the pipeline for Ocean Startup Project and for Canada and some international companies as well. So looking forward to seeing applications to our challenge. Folks, before we get into our panelists today, one of the things that we get to do on these Ocean Solutions exchanges is highlight some companies, some startup companies that are doing really interesting work in this ocean space. The first company I'm going to talk about or hand the mic over to actually is Qualities. It's it was a winner in our initial cohort for the Ocean Startup Challenge. And really, really wonderful company that is coming up and doing some great things. And I'm going to turn it over to Abjit to talk a little bit about Qualities. They are out of Newfoundland, and keep an eye on these folks. Abjit, over to you.
Thank you, Donald. Yeah, my name is Abhijit. I'm the managing director of Qualities. So our company started in 2018 as a commercial inspection service company, and then we actually identified some key issues in offshore operators. And from there, we're actually developing a software product that can further augment the subsea asset inspection. And thank you to Ocean Startup Project that they actually gave us this opportunity to actually do this R&D and develop the product for the client base. Thank you.
Thanks, Abjit. Really, really appreciate the shout out to the project, but it's just a pleasure to work with Abjit and his team and watch the development that's happening there, because they are a company that is on the rise and is going to do great things in this space. The next person I want to turn it over to is Mike Kelland from Planetary Hydrogen. Mike is one of those entrepreneurs that if you could bottle him, we would have just massive success in the ocean sector here in Canada. And so Mike, I'm going to turn it over to you to talk a little bit about Planetary Hydrogen and what you're doing, both for the climate and for the ocean sector.
Excuse me, that's super nice of you, Donald. If I can, I'm just going to share a screen here and run through a quick deck just talking about what we're doing here. So if you could tell me if you can see that, I would appreciate it.
We can see that. Yeah, that's great.
Awesome. Awesome. All right. So hi, everybody. I can stay in the frame here. My name is Mike Kelland. I'm the CEO of Planetary Hydrogen. We make hydrogen while taking carbon dioxide out of the air and in the process restoring ocean chemistry. So I'm an ex-software entrepreneur, and I often get the question, why climate change? And my answer is that climate change is the only issue that really matters right now. So if we don't get it fixed, everything else is going to fall apart as well. And we're not making a lot of progress yet. So the question really is like, why isn't everyone working on climate? And that's even more frustrating because climate is a great opportunity. There's according to the Global Commission on the Economy and Climate, it's about a $26 trillion opportunity with the potential to create 65 million new jobs. And so our opportunity here is virtually limitless as we look to overhaul our entire energy system. And to give you a sense of what that means, right now the world emits about 51 billion tons of CO2 every year. So 51 billion of these balloons. And we're thinking big. Our target is to remove 1 billion tons of CO2 from the atmosphere every year starting in 2035. And that's a pretty ambitious goal, but I think it's the level of ambition that everybody who's working on climate needs to have right now. If we're going to make a dent in the challenge. How do we do that? So we make the greenest fuel on Earth, is what we say. And in order to do that, we start with hydrogen. And our play in the hydrogen market is that with current carbon credits, we can create the cheapest hydrogen in the world. And we do that by adding a special ingredient to hydrogen electrolysis, what's otherwise known as green hydrogen, that allows us to produce hydrogen and the stuff called hydroxide at the same time. With the hydroxide, we capture and store carbon directly from the air and transform it into an antacid for the ocean. Finally, that antacid locks that carbon away in ocean chemistry for hundreds of thousands of years. So this sounds kind of crazy, but it's something the Earth does all the time. And all our system really does is speed it up. So Natasha, you asked me to sort of focus on the energy industry for this talk. And what I was thinking about was like, what can we actually do with this negative emissions hydrogen at the end of the day? So we end up with a hydrogen with a negative carbon footprint. What can we do with it? Well, right now, the vast majority of the $150 billion in market in hydrogen goes into oil refining. And if you take, and it's basically used like a crowbar, it cuts up molecules of crude oil into smaller things like gasoline and diesel and things like that. So we, using negative emissions hydrogen, could cut down fossil fuel carbon emissions by up to 50% if we refined our fuels that way. But we could go even further with it, where if you took a biofuel, we could actually create a carbon negative aviation fuel. So you could actually take a flight that takes carbon out of the air as you fly. Over the next year, we're planning to build a pilot plant with the support of various partners. And as we do so, we want to engage in meaningful conversations about climate and hydrogen and the health of our oceans with members of this community and the larger local community. So what we're doing here is pretty new, it's pretty innovative, and it can be scary. And so we're here and we're listening and we're trying to engage with what other concerns come up from the community around our process. So finally, I'll say, to quote Greta Thunberg, as she says, our house is on fire and we must take action. We must do the impossible because giving up is never an option. So that's what we're trying to do right now. Thanks very much.
Thanks so much, Mike. I just love new, innovative, and scary, because I think I just think that's a great mantra for a company, and what you guys are doing is just cutting edge and demonstrates what we can do here in this ocean sector, and what relatively new companies can take on. So really excited, folks. Just before I get to the panel, we are doing a networking component of today's event. We're going to open breakout rooms after the panelists talk. You will have an opportunity to go into the breakout room with these fantastic panelists. So I'll give a few more instructions after the panel discussion of how to get into those breakout rooms. But right now, I want to bring in Melanie Nadeau, recently named top 25 most powerful women, I think, in Atlantic Canada. Is that right, Melanie? Is that what it was yesterday?
Thumbs up.
Yeah. So congratulations on that. Melanie is the CEO of the Center for Ocean Ventures and Entrepreneurship here in Dartmouth, Nova Scotia. Took on this mantle recently and is already sort of redefining Cove and building on a very strong foundation, but just doing some really remarkable things. I know, Melanie, that you had a recent announcement around Stella Maris. Do you want to tell people a little bit about that?
Absolutely. So thank you to the Ocean Startup for allowing me to moderate this panel. I'm excited to get into the discussion, but glad to talk about Stella Maris. So Stella Maris is a project we announced a couple of weeks ago, and it's part of our testing, validation, demonstration program. And it is a infrastructure that will be deploying about 100 meters from our wharf. And that infrastructure will house 10 to 12 different types of sensor technologies that are going to be put on the platform to demonstrate, market the technology, to do some R&D. So these are different companies that have anything from sensors focused on pH to different types of visual cameras that are going to be put on the sensor, to all the types of characteristics that you could think in terms of data collection for the oceans. So it's very exciting for us. We announced it just a few weeks ago, and we will be putting Stella Maris into the water in early June. And so everyone will be able to see it. What's also a big part of it is we will have a on-land observation center. So we will allow people to come in, some training to be done based on the data, based on the technology that's there, and there will be visuals for people to see. So our observation center actually just arrived yesterday, and we'll be kitting that up over the next couple of weeks. So very excited about this new platform that we're launching. So great, so great. Melanie, I'm going to turn it over to you. Let's get to the panelists and the conversation. So thank you so much for doing this. Excellent. Well, thank you to our panelists for joining this conversation. And in light of your introductory remarks and International Women's Day yesterday, I will start the panel with Moya Kyle, who's the CEO of Pangeo Subsea, and ask her to give a brief intro to herself and to her company. And following that, I'll ask Jason Heyman, who's the CEO of Sustainable Marine Energy, to do the same. And last with Neil Hamel, and I apologize if I'm saying your name wrong, is the head of US Innovation and Venture and the Venture Hub at Ørsted. Our panel, of course, is focused on offshore renewable energy. And so I will leave it to the panel to give their intro, and then we'll follow through with a moderated discussion. And my understanding is that we are active on the chat. So if you do have questions that come in, I'll be watching that as well to make sure that your questions can get put forward to the panelists. So with that, I'd like to start with Moya.
Well, thank you very much. Thank you very much. And it's great to be here today to participate in the Ocean Startup. As you said, my name is Moya Kyle. I'm based here in St. John's, Newfoundland. My background is engineering. I've been been around since for some 30 years within the industry. Started in the oil and gas sector, focusing most of my earlier career in Norway. Came back to Newfoundland in the early 90s, started an engineering company. And there's only so many people hours of engineering that you can sell. And so the opportunity came along in around 2006 to get involved with technology, which was something which always intrigued me, particularly having spent so much time in Norway, and they're great supporters of technology, believing that, you know, it's an enabling commodity with regards to their energy sector. And I co-founded Pangeo. Pangeo is a technology company. We're actually using acoustics, using very high resolution acoustics to image the subsea bed. So very much like an MRI will image your organs, we'll image what's in the subsea bed. So for site investigations or pre-route surveys, we're imaging, we're clearing the seabed for boulders. Certainly in the renewable energy sector now, and in Europe, UXOs are a significant concern, very high risk concern. So our technology can actually wrap an acoustic boundary around an anomaly, whether it be man-made or a natural anomaly, and we can provide that data real time on board the vessel. So a really exciting technology. Started off in the oil and gas sector, and as we said, now we have evolved and we've reinvented ourselves and are leaders now in offshore renewable energy sector globally.
That's great. Thank you, Moya. I'll ask Jason if you can jump in and share your background and your business.
Sure. Thanks, Melanie. Yeah, so my name is Jason Heyman. I'm CEO of Sustainable Marine Energy. I originally started out, I suppose, in the marine space as a naval architect. So went, of course, thinking I was going to become an illustrious designer of racing yachts, and had to go and earn some money while I was at university, and ended up working in a shipyard, putting together an FPSO topsides. And so, of course, as you sort of realize, there's a commercial side to the business, and ended up, I was a bit like Moya, working in oil and gas initially, and then working for a company in the northeast of England who was designing lifting and handling equipment for deploying plows and trenchers and all sorts of equipment subsea. And we got asked to do an interesting little project where a German company came and asked us to figure out how to install their tidal turbine. And that was, gosh, about 12, 13 years ago now. I found the challenge to be quite interesting, and took it on, and actually went out there and ran the project for them, where we installed their turbine out in Korea. It was the first generation bottom mounted tidal turbine. And when we looked at it, we said, gosh, this is a really difficult and very expensive thing to do. And so we thought it must be a better way of doing it. And so we sort of had a look and thought, okay, well, we can make this maybe a little bit more like conventional naval architecture and a bit more like normal vessels in terms of being able to install them, maintain them and everything, then maybe we've got a shot at making this thing achievable. And yeah, so that was a little bit over a decade ago now. like why we went from being a consultant services selling engineering hours to saying, okay, now we have to jump off the cliff and try and develop our own project. And so I suppose another overnight success, 10 years in the making. So here we are now, I suppose, having demonstrated our first prototype quite successfully in Scotland and then in Grand Passage over the past couple of years. So you just sort of see it there on my shoulder. And we've actually just beginning of the month launched our, or beginning of last month, sorry, launched our next generation platform, which we hope will prove that tidal energy can be delivered effectively at force here later this year. So that's the challenge, and that's what we're doing.
Great, thank you, Jason. And last but not least, Neil.
Hi, Melanie. Hi, everyone. And my last name is Hamill. You were very, very close. No worries at all. Nice to be here with you all. Very happy to have been asked to join this panel. I'm a little bit of the odd man out in the panel, in that I'm actually very new to this industry. I joined Ørsted in June of last year to head up the U.S. Innovation and Venture Hub. My background is entirely in early stage startup technology companies. So about 14 years, been co-founder, investor, early employee, mentor, advisor. I helped spin out Mass Challenge Rhode Island here in the state. So a lot of experience working with early stage companies across tons of sectors, but also 12 years working in corporate innovation and venture capital, and usually one of the first hired to help to think about the structure and grow it from here. And so that's what I've been hired to do at Ørsted. So this is our first innovation hub based in Providence, Rhode Island, but we're thinking about the model and how we expand it globally, and also rethinking how we relaunch. We used to have a venture capital arm in San Francisco that was winded down before I joined, and rethinking how we're going to launch that model probably in 2022 or 2023. And at the moment, the hub's focus as far as executing or working with technology companies, I am the external arm of the innovation team. We have an offshore innovation team in Denmark. That team's very much focused on some big projects like, I heard green hydrogen. They started working on that a few years ago and now have spun out a pretty big team focused on that. They're focused on things like floating offshore wind, energy islands, and I'm focused on how we bring external companies to the table to help us either solve more immediate to midterm problems with our lease areas that are in some kind of development phase or nearing bid phase. And I'm also, once the projects like green hydrogen stuff get up and running and they want to look for companies to fill gaps in that, I would help sort of scout for the companies to do that. So I'm really the external arm of the innovation team.
Thank you, Jason. And it sounds like you're also a great contact to have for folks in this audience. So thank you to all three of you panelists and giving your intro. I'm going to lead us off into a discussion. And I think I'm going to pick up where you left off, Neil, on talking about, when you think about offshore or tidal energy or offshore wind or doing site characterization in the offshore environment. What do you think are some of those near-term, you called it immediate to mid-term problems or challenges that you're seeing in the industry where there are gaps or unknowns or innovation required to close those gaps and change the dynamic that you're trying to address? So I will ask all three panelists to answer that question, but I'll start with Neil.
Sure. And my fellow panelists will probably be able to answer this in a far more technical way or go a little bit deeper, but all of the East Coast projects that we're that I'm focused on at the moment. I mean, we only have Block Island Wind Farm is the only one that's operational. The rest are all in development phase of some kind. And usually right now, most of them are in the site investigation phase. In fact, Revolution Wind is the only one that kind of has closed that part of the process. So that's very much top of mind for all of our, we call them asset projects. So all of our asset project managers, site investigations top of mind. One of the most difficult things about that for them right now is there are different ways that we can do site investigations in Denmark, in the UK, versus what we can do here in the US. And a lot of it is based on the regulation that's in place, something that I'm trying to come up to speed on right now and understand what we can do now versus what we can show we can do, but by regulation standards, we aren't able to do. And so that's one of the things that's been on my mind as far as boulder identification goes, cable routing and planning goes. One of the things that I'm just starting to dig into a bit more is understanding what kind of testing. So if we're thinking about like benthic testing, like what can we do on the vessel versus like right now, just about everything is sent out to a lab. What can we do to shorten the time frame and do that testing on the vessel itself? Might be a ways out, but I'm hoping it can be sort of a midterm solve. And I think the most near-term solve comes in possibly how we're doing this stuff. I mean, right now it's towing things, behind vessels, and we're racing faster and faster to getting autonomous underwater vehicles and other robotics to be able to do this stuff. But again, I think a lot of it is thinking about what can be done within the regulations, because about 50% of the data we gather on site investigations is for our own internal use for construction, but the other 50% is just for what the regulators ask for. So, what can we do to make those two processes be a little bit faster, cost a little bit less, because this is about a 5 to 8 year time frame and hundreds of millions of dollars. So you can see how that then trickles all the way down to the cost of the energy itself. So those are some of the things that are on my mind now as I'm working with the site investigations team and the US lease areas that we have.
Right. So, and I would expect that 50-50 split that you see for your business site investigation and the regulatory requirement split, even though regulations are different from jurisdiction to jurisdiction, I would assume that if you're using sensors or robotics in your work in New England, that would likely have an advantage in other parts of the world as well in terms of how you conduct site investigations.
Yeah, it's pretty interesting to see that we do things differently. There are a few technologies we use in the UK, for example, that we would like to use here that we can't. And I'm sure it's going to be vice versa once we actually are able to do some new things here.
Interesting. I might pick up on that point a little later. I'll go to Jason. And what are your thoughts?
Yeah. So I suppose two things. So first thing is we operate in a pretty unique and challenging and dynamic environment. So it makes anything on the water difficult and challenging. We're there because of the energy density. But what it means is that, when you're operating in water that's flowing very quickly most of the time, if you require things to be performed like survey tasks that you've got to perform in slack tides, then you've got very small windows of opportunities, and you might only have 1 or 2 windows a day in which to do, for example, deployments of instrumentation. So you've got to be, your utilization time of any assets can sometimes be very small. So you've got to be ready, and you got to be dropping the gear onto the ground and make sure you get 100% right first time. And then you might not have an opportunity to go and pick up that sensor. For example, it might be an ADCP that you're putting there to measure current speed. You might not be going back to pick that up for 30 days. And then you go and pick that up in 30 days, and you want to ensure that it's not a dice throw as to whether you're getting good data when you go and pick that up, because otherwise you just lost a month and you just paid for 2 vessel deployments for nothing if the thing landed upside down or didn't work for some reason. And all of those things do happen. So I think being able to move away or into systems, it's a little bit the same with our platforms versus bottom mounted. We've been looking at ways to get more real-time data, so we know whether the sensors and the instruments are working and whether we're getting quality data, so that if something isn't functioning, we can go pick it up and retrieve it then, not waiting to the end of the sampling cycle and then picking it up and finding we didn't get the complete data set and having to redo it again. I think it's sort of trying to reduce the number of times we have to go and deploy to try and get the data that we're after. That's a huge one for us. And then, yeah, I suppose, so generally, I suppose it's a general packaging and wrapping of systems such that they can be deployed and survive in that environment too. So we're finding that, there's all kinds of stuff that rolls through a tidal site at 10 knots can be pretty damaging to sensors and gear. And so it's sort of thinking about, okay, how do we protect the gear? How do we make sure that we make it easy to install? Preferably that we expand the installation windows so that we're not just working at NEEPs. So I think it's sort of about, really opening up the working windows and reducing the number of times we need to go do something to get the data that we need. And that's sort of, I suppose, coming back to the point too about the sort of what the regulators require. I think that's a massive one as well, trying to understand what the regulators require. This is a new field. We're learning at the same time they are. What format do they want the data in? How do they want it packaged? What do they, quite often we find that they're specifying things that are actually physically impossible to obtain in a tidal site. And we have to sort of step through that process and try and find new ways of doing that. And then the other one, which I'm sure Moya will cover far better than I can, is around the geotechnical side of things. That's a real challenge in tidal sites because, of course, all the fast current takes away all the sediment. You're just left with scoured rock, but you really need to understand what's there in terms of that rock. And it's very, very, very expensive and very time consuming to go and try and do samples or take physical boreholes or coring samples in a tidal site. Well, we can do it with our rig. I think we're about the only company in the world that can at the moment. So, yeah.
Well, thank you, Jason, for that great perspective for tidal energy. And it was a great segue for Moya leading into the seabed. And what are some of the challenges that you see there in the offshore renewable space?
Yeah, thank you, Jason, for that. And certainly, we're listening to our clients. So just as Neil said, the industry is saying we want more data, we want better data, we want it faster, we want it cheaper. And so, what does that mean, really? And so it's being able to collect more data on a platform. It means trying to get on smaller vessels, so reducing your crew. So utilizing more focus on artificial information, so AI, so that you can collect data faster with modifying your algorithms such that you're auto tracking or auto picking your data, and even looking at trying to focus more on onshore remote data centers. So that you can focus on data acquisition offshore, but then you can do your processing onshore. Really important to get folks off the boats and onto the beach. Certainly, we see a big difference between campaigns in Europe versus campaigns in the Eastern Seaboard. In Europe, lots of vessels, primarily because of the oil and gas sector in Europe. And so the availability of vessels is there. We don't see the same asset in the Eastern Seaboard. So we have to be very, very conscious of the availability of vessels, the type of vessels that are available, and hence then looking at, the types of platforms that we're using to collect our data off. When we started out in the offshore, and when we started out in the oil and gas sector, these big, large work-class ROVs were a dime a dozen in Norway, in Aberdeen, and throughout Europe. But certainly in the Eastern Seaboard, looking at smaller ROVs, and then of course, how do we then, rather than a remote operated vehicle, how do we put our sensors on a towed vehicle, or better yet, on AUVs? So these are the types of challenges and type of challenges that we're looking at providing solutions for, and great opportunity for startup companies to collaborate with us and to really accelerate their commercialization.
Thank you to all of you for sharing your thoughts on what are some of those challenges that you see within your specific industries in the offshore space. So I heard, real-time data, sensors and robotics, reducing operational costs, accessibility to data, reducing crew size, time on the water, collecting data faster, onshore remote sensors, processing of data, improve site investigation. So those are quite a few there. So with the group that we have, the audience that we have today, who are either budding entrepreneurs, have their own businesses, are looking to get into this market and got some solutions for you. How do they go about working with, say, a large company like Ørsted? What are the advice you have for a company trying to deliver a solution or share a solution or understand how they can better tackle those issues at a more granular scale? So I'm going to jump to you, Neil, and see if you can share any kind of recommendations for those entrepreneurs in how they can work with the offshore wind market.
Sure. I'll try to break this up into maybe 3 different stages of companies, because I think it's quite different. Like, I'm mentoring a company right now who's in the very early stages. They came out of university, they had a pretty unique data processing platform for images that they're taking on the ocean floor. And, that definitely has applications into site investigations, among other things in the offshore wind industry. The problem is that, I mentioned site investigations 5 to 8 years long and very expensive. When we're looking at gathering data in our lease areas, these are huge areas, right? So you need to think about how you can do whatever you're doing at a massive scale. And just the fact of the matter is, the way that site investigations are done, you have to hit the timing just right. You usually have to, bid in order to be part of a bidding process in order to be selected for it. So what I actually recommended to a company like that was, don't start in offshore wind. I actually had told them that their solution, they were trying to think about the different markets they could go after, because their solution actually works in aquaculture. It works for coral reefs, and it could potentially work for site investigations. So one of the things, when we're looking at aquaculture, the barrier to entry to get into an aquaculture farm and do what they need to do in a smaller area is really low, but it can prove a ton, and it can also help get them some operational revenue flowing. So my recommendation to them was pick a lower, barrier to entry kind of place where you can start proving in that industry, because one of the things that we're looking at as Ørsted is, what are some mature technologies in different industry verticals that we can apply to offshore wind, right? Rather than trying to just go straight to, let's, sort of incubate this company for 10 years and hope it works out. Because that's just really, really tough to do. So if you're a very early stage company, you certainly want to show proof coming out of the lab. You certainly want to show some proof offshore before, a company like Ørsted is ever going to let you do tests in their lease area. Now, I guess that depends a little bit on what you're doing. If you're a company that we don't need to apply what you're doing directly to one of our turbines, and you should definitely understand the regulations, so that if it's not very costly for us to potentially allow you to do something in one of our lease areas, and it's just that you need that ocean space, maybe we can make that happen. But there just are a ton of barriers to getting to pilot something in one of our lease areas. So if you're in the early stages, get creative, find other ways to prove what you're doing in a lower sort of barrier space. And then the mid-stage companies, I think what I'm running into, and I say mid-stage, I'd say you're a Series B type stage company. You've got, capital isn't a problem really for you, and you've got a commercially available solution that you're now trying to sell. but you probably don't have a whole lot of offshore wind experience, and you may not have a ton of experience even just doing a bigger project. So one of the things that I'm trying to do is develop the types of programs where we can allow you to gain that kind of experience. So essentially what Ørsted would do is design the type of test in a smaller scale that we would want you to accomplish, right? And then we'll, through a partner of ours, will allow you to go offshore and do that. So it de-risks from Ørsted a little bit, but we're proving you along the way. And it's a much faster route to then having a pilot project with us. And then sort of the third stage company example I'll give is, you're probably well proven. You're an experienced company. You've been around for a decade or more. You have a ton of experience in maybe another industry vertical. Maybe it's the naval industry, for example. But you are not a tier 1 size or a tier 2 size supplier. So just frankly, if you're trying to get through the typical procurement process, you're probably hitting a whole bunch of snags along the way, or things that you can't meet. So that's where, hopefully other companies like Ørsted have groups like the Hub, where we try to help pare down that procurement process to more of a streamlined process, get these companies that are small but experienced and have technologies that are adaptable to offshore to get smaller projects started, and then help you scale up to the size where we can you can actually then start, applying through sort of tenders and normal procurement processes. So those are sort of the 3 ways that you can certainly work with Ørsted if you're thinking about, which one you fall into. And I think probably pretty similar to other big companies. And I would just say, be wary when, you start talking to them and they're interested in what you're doing and you want to scope out a project, understand that timeline, because it is way longer than you think it's going to be. I mean, I absolutely shocked the folks that I'm mentoring when I told them about the timelines for the industry. So that's just what I would have in mind.
And just a quick follow-up, when you talk about the program for your Series B, say, type companies, is that a program where a company would apply to, or they just build their relationship with Ørsted? What does that look like?
Yeah, for year 1, we haven't publicly announced it yet. It is just starting. And for year 1, it really, what we'll end up doing is we'll announce sort of the focus areas we're going to have. For year 1, it does happen to fall on site investigations and marine mammal monitoring. And we'll narrow those down. I know those are pretty big topics. And so it's not really an application process. I think for year 1, we'll really sort of like hand pick, because it's only 2 to 3 companies just to get it started. I think the goal is that in the future, these would be not necessarily cohort, it'd be sort of rolling applications, and we'd be taking 12 to 15 companies, and it would be an application type process. But for now, just talk to me.
Thank you. Moya, I'd like to go to you now and ask you, based on your experience, so you've been in the offshore oil and gas, you started your business in offshore oil and gas, you've moved into the renewable energy space. For entrepreneurs and startups, where I'm sure there are entrepreneurs who are shifting from oil and gas, getting into this space based on, what Neil said, all that experience that exists. What type of advice do you have when you look at your experience in oil and gas now shifting to offshore renewables? What advice would you have to those entrepreneurs?
Yeah, well, certainly, the oil and gas, it's, there were significant barriers to entry, just because the oil and gas had been around for many, for 20, 30, 40 years. And so, adjusting to change, adopting new technology with, it's tough to get involved and to get there in the oil and gas sector. We certainly have found, because the renewable energy sector, is a newer industry, younger minds, they're certainly more open to technology and to new ideas, to innovation. And as Neil said, you've got to find the Neils of this world. You've got to find the champions within that within the operators to who understand what your value proposition is, and it's really important to be able to articulate very succinctly what is your value proposition. How are you going to save them money? How are you going to make their job a safer place to be, and deliver their product to the market sooner and cheaper and on budget. So it's really important to drive those areas for the operator. And like I said, to understand what your value proposition is. So, as soon as you talk about marine industry, as Neil said, it's expensive to get out there and showcase your technology. So you do need to be able to crawl before you walk and walk before you run. And certainly, I'm really excited by the Stella Maris program that you've just rolled out, because that allows you to actually demonstrate your sensor in a very economical way. With our sub-bottom imager, when we're looking at having to go offshore, I mean, it's getting a vessel. I mean, you're talking about hundreds of thousands of dollars just to be able to get your kit in the water to demonstrate it to your client. So that's a great opportunity there to take advantage of that. But also, getting involved with, proper networks. So like programs that we have here today, but, joining organizations or participating in conferences. And if we ever get to exhibits, doing, the AWEA, IPF, all of these, offshore renewable energy networks are excellent opportunities to get to understand who the players are, who the operators are, because albeit Ørsted they're a very mature operator. There are other players within the industry who aren't as mature, don't have the roadmap so well laid out. And so every operator is different. So you really have to be flexible and try to find the folks within that organization who can be your champion. And once again, like I said, being able to articulate what you bring to the table for them in that value proposition.
That's very good advice. I'm going to go now to Jason, because there is obviously a lot of synergies between offshore wind and tidal energy. I'm interested in understanding from your point of view, how do startups engage with the tidal energy company? And when we talk about going in the water, the tidal environment is tricky, it's challenging, you've already alluded to that. So what advice do you have there? How do you get that on water time, or what would you like to see before you're engaging with a startup who's developed perhaps a new sensor or something that can enable the deployment and the operation of your tidal turbine?
Sure. So I mean, of course, we're the opposite end of the spectrum from Ørsted, maybe in 50 years' time. So we're a little bit less structured and a little bit more approachable, but at the same time, actually, in some ways, so innovation is really incredibly important to us, because we've got so far to go on the journey, but we've got to be so careful, because what we're doing is already quite innovative and very high risk and very challenging. And so we do tend to find that we try and walk this tightrope where we're trying to use, to the greatest extent that we can, very much proven and well-backed solutions. We use Siemens power conditioning equipment. Our largest shareholder, Shuttle, build our turbines. We try and lean on bigger entities, if you like, and their delivery capability quite often, because we are quite small ourselves. So when we do go and look how we're going to solve something, and we look for people to work with, generally what we're looking for are people who really, I suppose, have got their act together and are ready to actually do stuff practically in this environment. And we've really, I'm going to be honest, we've been burnt a few times, by people coming, great idea or a great bit of kit, but just no experience in how to deploy it. And they don't understand that cost to you in terms of your time, or tying up your vessel, or even allowing access to the platform, or trying to integrate their equipment onto your platform. So, you know, we've actually found initially we were quite generous. We were quite, oh yeah, hey, anyone's got a great idea. And then we just found like, wow, we're really, this is just actually distracting us from core objective number one, which is getting this thing working reliably and solidly and, you know, properly. So we're now find ourselves in a thing where we're being quite targeted about what we're looking for. And maybe actually, maybe we do need to get a bit more structured like the Orsted thing and just put those up and then say, right, if you can deliver if you can demonstrate that you can tow your thing behind a boat and smash over a couple of logs with it, right, send us a video clip of that and then we'll have a chat with you. You know, I don't know, because it is something like that, because it is really challenging. You know, you want to encourage it, but at the same time, it's just, it can be brutally difficult.
You're on mute.
You're on mute, Emily.
I'm just going to reach out to the audience, and anyone who's got a question, please put it in the chat, and I'll make sure to cover those off. We've got a few more minutes. You've already all kind of touched on this to some extent, but there is a technology thrust, if you will, around the entrepreneurs that, if I could say, Don, that are part of the Ocean Startup Project, that are focused on different materials that are used in the ocean space, different sensors, robotics. So we've talked a little bit about that. So diving in maybe from a more technical angle, for those that are working in these kind of key technical areas, developing different solutions, is there any kind of nuggets there that you can share, or opportunities that you see within your business, whether it's in materials, for example, or you know, even more so on sensors? If you could be more specific on what are the type of sensors that would be really valuable in better understanding your physical environment, or your or doing your site investigation, or using LiDAR, or different ways to use LiDAR for offshore wind and so on. So perhaps, and even robotics, like what type of robotics are good in the environment that you're working in. So I'll look for a show of hand, whoever wants to kick that question off first, and I'll start with you, but I'll ask all three to address that one. Anyone want to start off?
I'm happy to give a couple areas where, as far as sensors and robotics, some things that I've had discussions on recently internally. One of the sort of the vehicles that we're using at the hub here is these open innovation challenges, and the one that I inherited actually when I started was with the foundation coding team, and one of the pretty interesting challenges that you know, we're going to face as Orsted is our foundation coating solutions for below the water. You know, originally were meant for the lifespan of the original turbines that were put up, were somewhere in the range of 20 or so years. And now design lives are pushing 35 plus years. And so just naturally, we're going to have to find ways, and we certainly already have done repairs on some of these foundations. We would be pretty interested to find ways using robotics to do those repairs, because it's pretty time consuming and dangerous to do it from a human perspective. So that's something that that's a very specific use case that we're interested in, that not just any, you know, you can't just throw on any kind of sensor or arm or something and any AUV can do. So that's something that might be a bit more custom solution, but be pretty interesting. And then sensors wise on the turbines themselves, I've had a few conversations recently around, naturally there's the preventative solutions coming from IoT, but also sort of like self-healing and new materials as far as adhesives and coatings and electrical wires and lubricants go. So I've had some top level conversations on those so far. So those are a few that just came to mind for me from recent conversations.
Great, thank you. Anyone else want to jump in on that one?
Sure. Yeah, I could probably give you a quick No, I mean, so one of the things that we, I suppose, on the sensor front, or the is really environmental monitoring is a big focus for us at the moment. It's a massive challenge. I think what we can achieve technically versus regulator aspirations or hopes or sometimes demands are very, very wide at the moment. A very wide gap between what can be technically achieved. And so, you know, if you can imagine, you know, we're looking at all sorts of technologies around echo sounders and different acoustic cameras and everything. Sort of, how do you tell, how would you tell, or first of all, how would you see a fish come past your turbine and how does it behave as it goes past? And then what fish was that, right? So, and what, how do you know it wasn't a stick? And so, because while something goes, so, and but that's the information they're asking for. And so we're trying to figure out how to get it. And I suppose one of the problems too, is that there's some fantastic gear out there in terms of acoustic cameras and everything, but they're incredibly expensive. But it also requires a human eye to watch the thing, a very well-trained human eye to watch the thing and then interpret what they're seeing and make their best judgment call about what it is. So some of the things that we're seeing, some of the developments around, of course, machine learning, artificial intelligence that's being applied towards, you know, let's say automatically filtering or processing some of the stuff that could actually generate sort of automated reports is pretty interesting. And then, and also, you know, maybe there are applications for LiDAR and other types of technologies or other types of solutions there. So that maybe won't be as affected by things like turbulence and bubbles in the water, which of course echo sounders and things struggle with. So so that's one particular area of focus, a big area of focus for right now. We're actually investing heavily in that and very, very keen to talk to anybody who's got any bright ideas in that space. Because that is basically the barrier to, or what's keeping the market closed in Nova Scotia right now, effectively. Then I would say that the next one, of course, we're always very interested in anything that can, as we said, that can sort of reduce sort of survey or data gathering times. So if someone comes up with a clever UAV that can work in tidal space, that knows how to scoot over to the edges and just come out and play during the neeps, that'd be pretty cool. Love to see that one come to fruition. And then we're doing some pretty cool stuff at the moment around, so we have a drilling rig that we operate remotely from a vessel. We use a multicat, we drop it on the seabed, and we install our drill and install our anchors in one hit. And then we're deck to deck in less than an hour. With anchors that can hold 150 tons. But then, of course, we need to be able to go and service those, and we also need to be able to inspect cables and everything else. And using free-flying ROVs in tidal situations pretty challenging. In fact, well, yeah, I've seen all sorts of fun things from people trying that. You know, one ROV got a free trip from the Orkneys to Norway. So what we see is that we've got to come up with solutions that are probably, maybe little tracked vehicles on the seabed type solutions that can sit there and that can actually operate sort of during the tidal cycle, or sort of hunker down once again while the tide's raging and then continue doing their job when it's not. There's actually in Korea, they were developing something called the crab there for a while. It was pretty cool. Maybe not quite that sophisticated, but yeah, I think it's things like that. They can sort of, they're intelligent enough to sort of know when the conditions are right for them to come out and do their jobs, and then shelter when they can't.
Maybe Melanie, I can pitch in here and talk a little bit about our technology roadmap from a sensor development perspective. We have a very aggressive technology roadmap, and certainly it's supported by the drive now for Canada to be net zero by 2050. We're looking at incorporating our sensors onto an AUV, and not just to be to collect multi-sensors, so not just our sub-bottom imaging technology, but also being able to incorporate side scan sonar, multi-beam, other video sensors. One of our most creative concepts now is actually looking at creating a crawler that can acquire not just our acoustic data, but we're actually incorporating resistivity. So incorporating electrodes in the crawler to collect resistivity. So now on one path, and this is more focused on an application of pre-route surveys, we can collect geotechnical data as well as acoustic data in one pass. So, you know, all of that requires, you know, a significant amount of components, everything from, you know, how do we manage all this data? I mean, we're collecting, you know, terabytes of data per hour and managing all that data offshore, looking at, you know, certainly remote accessing that. And once again, you know, incorporating, like Jason said, you know, the machine learning and AI, which will all certainly significantly accelerate the adoption of that type of technology into the marketplace. You're on mute, Melanie.
Oops, thanks, Moya. I'm going to have a quick follow-on question because I'm curious about this, and then I'll wrap it up with a closing comment before we go into the breakout. All of you have talked about machine learning, AI, large amounts of data. So in each of your businesses, you're obviously working in this space. Do you, are you hiring internally for that kind of skill set? Are you looking at external companies to be able to access that machine learning AI capability and enable your, you know, products go to market? How does that work in each of your businesses, or how do you foresee getting access to that kind of capability in the short term?
From our perspective, we would subcontract that out. I mean, that's a niche, and you know, we don't want to we specialize in, you know, 3D volumetric data acquisition. You know, we don't want to be everything to everyone, and so, and particularly with AI, and it requires a completely different skill set of folks that we have on board. So, so for that, we absolutely look to the brightest, you know, in the country, and would look at subcontracting that out. So, you know, wide open for people to come knocking on our doors and sharing with us what they can deliver.
Great, thank you. And is that the same for Neil and Jason?
We have a small team that focuses on this, so we are thinking about hiring, but because it's a small team, they definitely aren't the be all end all. We're completely open to contracting it out, and I think it's pretty specific on each particular use case or what we're trying to do, especially since right now a lot of the AI and machine learning solutions are pretty use case specific. So especially in the near term, it's going to be a ton of contracting out, but we do have that small team who's thinking about this long term, and we'll hire around that as well.
Great. And how about yourself, Jason?
Yeah, so I think, well, so someone put a comment there about the Pathway project, which is kind of an interesting one. That's something we're actually doing with OERA, DP, and Force at the moment, where we're actually working with Dow and some clever people over there with their machine learning capabilities, and seeing if we can apply some of that or some of the programs which have actually sort of come from industry and other technologies. So there's quite a wide international collaboration in this field, where people have been looking at some of these things for a long time, but saying, okay, if we take these programs that maybe were designed to do one specific thing and sort of try and mush them together, if you like, with a more capable system, what could that produce? I mean, on our side, we're tending to find we're growing, and we're trying to hire someone at the moment to a head of marine ecology for our team there in Canada, to help coordinate some of this work. And I suppose that's the way we generally work. So we do subcontract out, we do some stuff with partnerships, and we generally try to make sure we have enough resource internally to be able to manage the projects, if you like, and make sure that they get, you know, delivered in the sort of timeline that we need them to, because yeah, just academic projects, I'm afraid, don't tend to get you there. The outcome is always more work, as they should be in the academic environment, whereas we have to deliver within generally budget and timeline. So.
Great. Well, thank you to all three. I see Don joining, so that means we're getting the boot. But I will say that Moya mentioned this, Canada's goal to be net zero by 2050. That's Canada's targets, but the rest of the world and countries around Europe and in Europe and other parts of the world are also moving towards those kind of targets. So we know that offshore renewable energy is going to be there for a long time. It's a growing sector. And I think all of our panelists have really shared really good insight into what are some of those either niche areas or challenges that this sector needs to address in the short and the medium term. So thank you to all of you. So Don, I'll pass it back to you.
Okay, thanks. Thanks so much, Melanie. Really, really appreciate you moderating this and taking this on. And thank you so much to the panelists. That's a lot of time, a lot of energy, and we really, really appreciate you making time for us. Folks, again, what we hear is just there's so much opportunity in the ocean sector. There is so many things happening right now. There's so much funding and so many resources here in Canada to help you get started to solve some of these problems that you heard about from these remarkable people today. So please follow along with the Ocean Startup Project, and we're here to help you and get you started and get you on the right foundation. So keep an eye on us. And again, thank you to the panelists and to Melanie Nadeau for moderating. Thank you also to Natasha Legay, Eric Siegel, and Katie Leard, who make all of this happen in the background. So folks, now we're going to get into the networking component. I'm looking at my notes because I have to read these, but we're going to go into some breakout rooms, and our panelists are hopefully going to stick around and join you, and you can ask them some more questions in these breakout rooms. So to navigate to your desired breakout room, click the breakout room button on your Zoom meeting panel, click join next to the breakout room you wish to participate in, then confirm by clicking join again. You can repeat those steps to navigate to other breakout rooms. If you have any trouble selecting a room, you can send a private message to Natasha Legay with the desired rooms, and she can help you navigate to the room of your choice. Also, just stay on and start talking, and we can figure that one out. So jump into those rooms, folks, and really looking forward to having a conversation with each of you in these networking rooms. Thanks so much.